Okay, we're going to solve systems of equation by substitution today. So for the first graph, how many solutions will there be at the graph below? Okay, so I see the first one has a point of intersection. So that is one solution. These lines are parallel, so that is no solutions. And then the last one is really two lines, so this is infinite solutions. And then when we solve today, we're going to be using substitution. So one of the tricks to knowing that you have no solution is when you get something like 0 is equal to 7. Something that doesn't make sense, something that's not 0. This statement, there's no variables, and the statement doesn't make sense. Okay. This one, for the infinite solutions, you'll get something like 0 is equal to 0 or 1 is equal to 1. Again, there's no variables, and the statement makes sense. Is true. Okay. There are three types of ways to solve a system of equation. The first is by graphing. That's what we did last week. The second is by substitution, and the third is by elimination. This week and next, we're going to be talking about substitution, and then following that, we're going to talk about elimination. Okay. So the steps to solving a system of equation, again, by substitution method, is we're going to solve the first equation for either x or y, it doesn't matter which. And then we're going to substitute the solution from step 1 into the second equation. We're going to solve for that new variable, and then we're going to use that variable to find the value of the other variable. There's a lot of steps, so let's go ahead and get started. Okay, so the first one, 6x minus 11 is equal, and y is equal to 2x minus 1. Today we're going to solve the system, and we're going to identify the solution, and then we need to verify the solution algebraically. A lot of that verifying algebraically. It looks like I didn't leave enough room, so I will go ahead and write these below. Okay, example 1 is y is equal to 6x minus 11, and y is equal to negative 2x plus 1. Okay, remember when we graph, if we were to use graphing, likely these two lines are going to cross like this, or cross in some kind of way. And so we're going to look for this ordered pair solution that is going to make both equations true at the same exact time. So the same x value and the same y value. So I know that the variables in both equations, so the x value and the x value has to be the same value, and the y value and the y value have to be the same exact number. So right now, I see that 6x minus 11 is equal to y, but these two y's are really the same. So I can go ahead and substitute in 6x minus 11 into the y in the second equation. So we're going to substitute the highlighted area into the y in the second equation. Okay, so I'm going to have 6x minus 11 is equal to negative 2x plus 1. Now we just solve this system. So solve for x. Okay, so I'm going to add 2x, and I get 0x and 8x, bring down the negative 11, is equal to 1. Add 11 to both sides. I get 0. on the left-hand side, I'm going to get 8x, and now I have 1 plus 11 is 12. Then I'm going to divide by 8. Okay, so I get x is equal to, and I'm going to divide the top and the bottom by a common factor of 4. So I get 12 divided by 4 is 3, and 8 divided by 4 is 2. So 3 over 2. Now I'm going to go ahead and, so that's step 1. Step 2, now I'm going to solve. I'm going to use my x is equal to 3 over 2 from above to solve for y. So you're going to choose either one of the original equations. I'm going to go ahead and choose the second one. So y is equal to negative 2x plus 1. I believe that's it. Negative 2x plus 1. Okay. And I need to substitute in 3/2 in for x. So y is equal to negative 2 times 3 over 2 plus 1. So y is equal to, let's see, 2 times 3 is 6. So negative 6 over 2 plus 1. I'm going to go ahead and simplify what 6 divided by 2 is 3. So y is equal to negative 3 plus 1. So y is equal to negative 2. Step 4 is the solution. Okay. The solution is an ordered pair. So x was 3/2 and y was negative 2. So the lines cross at 3/2 or 1.5 and negative 2. Okay, step 5 is our check. So we think that this is our solution. So we're going to check to make sure these are true. So I have my top equation. I'm just going to borrow this. And get some more paper. Okay, so I'm going to go ahead and substitute in to the top equation 3/2 and negative 2. So I'm going to get negative 2 is equal to 6 times positive 3/2 minus 11. And I get 6 times 3 is 18. And then 1 times 2 is 2 minus 11. Okay, bring down the minus 11, bring down the negative 2. I get negative 2 is equal to 18 divided by 2 is 9 minus 11. So negative 2 is equal to negative 2. So that solution verifies. Now we need to check the bottom one. Okay, so I have y is equal to negative 2x plus 1. And I'm going to substitute in, say negative 2 in for y. And negative 2 times 3/2 plus 1. So I multiply I'm going to bring down the negative 2 from the left, and then multiply 2 times negative 3 is negative 6 over 2 plus 1. Negative 2 is equal to negative 6 divided by 2 is negative 3 plus 1. So negative 2 is equal to negative 2. So again, these verify. So I know that the ordered pair 1.5 and negative 2 is the solution to my system. Okay, so we're going to do example 2. Example 2. 4x plus 7 and 4x plus 1. Okay, so I have y is equal to 4x plus 7. And then the second equation, it was y is equal to 4x plus 1. So what can I substitute? So first I'm going to take, this time I'm going to take something from the second equation. So I'm going to substitute the y value, 4x plus 1. So 4x plus 1 is equal to the y value. And I'm going to substitute it into the first equation. So it doesn't matter which equation is the top and which one's the bottom. You can substitute the bottom into the top or the top into the bottom. Okay, so 1, I'm going to get 4x plus 1, which was y, is equal to 4x plus 7. Okay, solve for x. So I get -1. I get 4x plus 0 is equal to 4x plus 6. I'm going to go ahead and subtract 4x from both sides to move the x's to the left. And I get 6 is equal to 0x, or 0 is equal to 6. And notice there's no variables, and the statement is false. Does 0 equal 6? No. So this is no solution. Your lines are parallel, like that. Okay, no solution. And then we don't have to verify anything when there's no solution, so we move on to number 3.